We're going to use the for each loop a lot in Unit 4 because many of the data types we'll discover are different forms of lists. Lists, tuples, and dictionaries are all data types that in some way implement a list-like structure. They have multiple values associated with one variable name. Another example of this, though, is something you've already seen, strings. Strings are effectively ordered list of characters. The string here on line 1, for example, is effectively the letters capital T, lowercase h, lowercase e, lowercase r, and so on in a certain order such that we can see that they spell out a certain phrase. So we can use a for each loop with a string as well. So for example, imagine we wanted to count the number of words in a string. We might use that to implement something like a word count in some kind of word processor. We might infer that we can do that by counting the number of spaces in the string. Every space generally indicates the end of a word in the string. And then we might add 1 to the end, because the last word isn't going to end in a space. To do this, we're going to use something a little bit more complicated. We're going to use a conditional inside of a for loop. The for loop will run for every character in that string, and the conditional will check something about the current character and act if it's a certain character. So the code starts by creating the variables myString and numSpaces and giving them their values. And then on line 5, it starts the for loop. The for loop says for current character in myString, which basically means iterate over each character in my string, and on each iteration of the loop, assign the value of the next character to the variable current character. So on the first run, the loop takes t as the value of current character, and then it checks if the current character is a space. And if so, it'll increment our number of spaces, or our counter of how many spaces we found. But t isn't a space, so line 8 is skipped, and now the inside of the loop is done. Goes back to the top, asks, am I done yet? No, there's still more characters in the string. So, loads the next one into current character. That's an h, a lowercase h. It checks if the current character is a space, again finds it isn't, and so it doesn't increment or doesn't add to the number of spaces. Now it's done, go back to the top. Am I done yet? No, still more letters. The same exact thing would happen for E, R, and E. And then we would encounter our space. That space is going to get loaded into our current character. Line 7 will again check if the current character equals space, but now it does. So line 8 is actually run, and now number of spaces is 1. This would continue for each individual character in the string. And sure enough, we would find 2, 3, 4, 5, 6 spaces. Our loop is now done, so our print statement runs, and it prints there are number of spaces plus 1 words in the string. Again, the plus 1 is because the last word in the string won't end in a space. At least that's the assumption we're making right now. And so sure enough, this prints there are 7 words in the string, which we can count and see. That's the correct answer. So notice a couple things here. First, notice that technically characters and strings aren't different data types in Python. In many languages, a character is one data type and a string is another data type, which is actually just a collection of characters. But in Python, a character is just a single character string, or a string with length 1. So when it iterates over the characters in the string, it's just iterating over smaller strings of length 1 that make up a bigger string. Secondly, notice the nested structures here. We have a conditional inside of a for loop. The for loop controls how many times the conditional runs, and each time the conditional runs, it controls whether or not numSpaces is incremented, based on whether or not the current character was a space. And third, on a somewhat unrelated note, notice our explicit conversion right here. We've explicitly converted the value of numSpaces plus 1 to a string. Notice especially that we're adding 1 directly inside the print statement. We're asking for the value of numSpaces plus 1, not setting numSpaces to itself plus 1. So after this print statement runs, the value of numSpaces will still be 6. We're not setting its value equal to itself plus 1. We're just printing what its value would be if 1 was added to it. Notice that we could have also done that just by using commas instead of plus signs. Then we wouldn't need our explicit conversion to a string. Although then we also shouldn't have those spaces because Python will add those automatically. Fourth and finally, notice that this code doesn't really work the way it's intended to. It works when we have very predictable strings like this one, but it would generate a lot of wrong results. It would say, for example, that an empty string, something with no characters in it whatsoever, would have 1 word instead of none, because even though it counts no spaces, it adds 1 when printing the result. Or if the string was just 5 spaces in a row, it would say that there were 6 words because it would count 5 spaces and add 1 to it, even though we can recognize there are no words. These are outside of what we would usually expect to find when we run this code, but when they happen, they demand some special processing. For example, to improve this, we might tell our code to ignore consecutive spaces or to assume the length of an empty string is 0 words.